I'm making this video just to help you really understand what it is you're supposed to be doing with the homework that is due tomorrow night, and to give you a little bit of extra help. Okay, so the first few questions aren't math calculation questions, they're recall questions asking you ideas around efficiency. And remember, at the very back of the booklet you have all the answers for that last 10 minutes of checking. So it's 20 minutes to try as many questions as you can. So just a few tips on the questions at the front. So thinking about what the efficiency of the appliance tells us. It's all about how much useful energy you get out for the total amount of energy you put in. The equation for efficiency, now that is something you have to be able to recall so that you can use it in exam conditions. So efficiency is equal to the useful energy that you get out divided by the total energy that you're putting in. And if you want to put it in a percentage, then you times it by 100. That's something you're going to need to be able to recall, to remember that equation so that you can use it. Okay. When we get to questions 3 and 4, the key idea about both of these questions is if something is more efficient, it wastes less energy. So in question 3, cars can go fast to get higher top speeds with the same amount of fuel if they waste less energy heating up the engine instead of moving the engine, the kinetic energy. And more efficient light bulbs, you don't have to pay for as much electricity that heats up the bulb, wastes energy, because you are paying for the electricity that gets you the energy you want out the light bulb, the light. Remember, there are answers so that when you've had a go at these questions, you can improve your answer if you need to. So question 5 is also another wordy question. Let's move on though to looking at some of the mathematical examples, because if you're struggling, it might help you to watch how they're done rather than just seeing the model answer at the end. So on question 6, a light bulb is using 470 joules of energy. That's the total amount of energy that goes in. And it produces 180 joules of thermal energy, 290 joules of light. So it's the light we want the light bulb for, so this is the useful energy that comes out. When we're calculating efficiency, we don't actually need the figure, the number of the energy that's wasted, because that's not in our equation. So if we're working out the efficiency, it is the useful energy that you get out, so in this case 290, divided by the total energy that you've put in this case 470. And then of course you can always use a calculator, so on the calculator I work out the answer and it's 0.62. If I times that by 100, I can put this as a percentage. It would be 62% efficient. Let me show you with question 7. So the power station is using 1,900 joules of fuel, so that's the energy that's going in, and it produces 1,250 of electricity joules. So that's the useful energy that's out. It's useful, so we're going to do our useful energy divided by our total energy, and then we can work out the answer on our calculator, which is 0.66, and then times that by 100 to say 66% efficient. Next homework is to try for 20 minutes as many questions as you can, and then stop so you can go to the answers at the back and you can have a look, correct any mistakes that you need to, and learn from those mistakes. Use the model answers to look at, if you haven't got it right, what it was you did wrong, so that you can see how to do it correctly, and therefore learn from your mistakes. It might be though that you were feeling quite confident, and therefore you might have got on to the harder questions. So from question 10 on, they get harder. Let's have a little look at question 10 in case you did get there and you found it too tough. So a power station has an efficiency of 0.85. We've been told the efficiency this time. We're being asked how much electricity is generated, so how much useful out energy if we have this much energy as the total in 5,000 joules. So with our equation, efficiency is equal to the useful energy that comes out over the total energy that goes in. We now know 0.85 is equal to something we don't know, useful out, divided by 5,000 joules. And we're trying to find the useful out. Now, one way some students like to rearrange equations is to use a triangle. And there is a video on my YouTube channel about triangles if you want to know a little bit more before our lessons this week. But if we were using a triangle, if we were to cover over efficiency, we'd need the triangle to tell us the useful energy out divided by the total energy in. So there's only one place left in the triangle for efficiency to go. If we put a times and a divide in our triangle, if we cover over efficiency with our finger, we are being showed the useful energy output divided by the total energy input. But this time we want the useful output. So if we were to put our finger over the useful output, we're being shown we can find that if we times together the efficiency, 0.85, by the total energy input, 5,000. And if we do that on our calculator, we will find it is 4,250 joules of electricity. Let's try question 11 with the same idea. So we're trying to find how much electricity is produced. So this again is how much useful energy, because the solar panel has got 870 joules of light falling on it, so that's the light energy that's going in. This is its efficiency. So we've rearranged the equation so we can practice using it again now. The useful energy that you get out will be equal to the efficiency, 0.32, times by the total energy that goes in, 870. And that will become, just do it on my calculator, 278.4 joules. Some of these questions then go on to practice the same rearranged version of the equation. You get as far as question 14. First of all, you're pretty damn awesome at working out efficiency questions. But if you do get this far, the rearrangement of the equation is slightly different now, because here we're told the power station has an efficiency and they want to know how much chemical energy must be burnt. So they're asking about the total energy in to produce, this is the useful, can't spell useful, sorry, useful energy out. So this time with our equation, efficiency is equal to the useful out divided by the total in of energy. We looked at the triangle before. If we made a triangle, useful out would need to be divided by total in, and efficiency would be over here. And therefore this time we're covering over the total in to look at what do we need to do. We need to do the useful output energy divided by the efficiency to work out the total energy that went in. So the useful energy out is 850 joules divided by the efficiency of 0.63. And that gives us an answer of 1,349.21 joules. Okay, so there we've worked out, and it makes sense because it's a bigger number, that more energy has had to go in to produce this electricity than the amount of electricity we've got out, because it's only 63% efficient. I'll just show you question 15 as well, just in case you want this extra help. So here we're still looking for the efficiency that's been given to us. They want to know how much light needs to fall on it. So they're asking for the total energy in. If the output, useful, out is 12. So now the total energy in is what we're trying to find. So we need to do the useful, joules, divided by the efficiency, just like with the rearrangement we used for question 14. And 12 joules divided by 0.51 comes to 23.53 joules, which again makes sense that we're putting more energy in than we're getting out because it's only 51% efficient. So 20 minutes trying what you can, and then 10 minutes checking over what you've done and seeing if you can work out how to make it a little bit better if it needs to be made better. That's the idea of this week's homework, having a go at showing me what you can from our efficiency work over the last couple of weeks. But remember, I'm only going to see your effort if you send me a photograph of it. You can do that by email, or you can upload on Google Classroom into the assignment that I set for you to improve on that from last week for those of you that wanted to send your pictures on Google Classroom. I'm really looking forward to seeing everybody else's homework in time for tomorrow. The ones I've already seen are pretty damn fantastic, let's be honest. So it'll be great to see some more.